Hello, my name is Jacob Kaplan, and here is my video 2 for ME210 Dynamics. And so, for this example of a particle in motion, I have my roommate Daniel, who traveled from our couch in the common area to the door that is the entrance of our apartment, which we measured to be 20 feet. And here's a video showing that motion. And so, from the stopwatch, we could see that it took Daniel 9.45 seconds to walk that distance, which was at a constant velocity that started from rest. So now, what if we want to know how fast he was walking? And so here are our givens and assumptions. So the distance that Daniel traveled was 20 feet, and the time that it took to travel that distance, given by the stopwatch, was 9.45 seconds. And velocity is constant. So in this case, that means that the acceleration is equal to zero. And we can also assume that there was no friction. He started at a velocity of 0 feet per second, and he started at an initial position of x equals 0 feet. And so now, how do we find the velocity that Daniel was walking at given those assumptions and those givens? So first, we have our free body diagram, which has the axes of x and feet. And so the particle started at x is equal to 0 feet and then traveled all the way to x is equal to 20 feet in a given time of 9.45 seconds. So how do we find that velocity? It's very simple. We can use our equation from the formula sheet that velocity is equal to the change in distance over the change in time, ds over dt. So now we can plug in our given distance of 20 feet and our given time of 9.45 seconds, and 20 divided by 9.45 gives us a velocity traveled of 2.11 feet per second.